This video is on systems of linear equations. We're going to be solving by substitution and elimination and graphing. The types of solutions for linear equations is we can have zero solutions when the lines are parallel, one solution, or infinitely many solutions, which means we have the same line. So when the lines are parallel, if I have a line that has a y-intercept of 4 and a slope of 1, which looks something like this. And then another line that has a y-intercept of, let's say, 0, -6, but the same slope, these lines will never cross. If these lines never cross, then they have no solution, because the lines will never intersect. This happens when the lines are parallel, meaning that they have the same slope but different y-intercept. Types of solutions when you have one solution or type of line is when the lines actually intersect. So anytime the lines actually cross, then the solution is the coordinate at which they cross. So we could have a line that has a y-intercept of 0, 3 and a slope of +3. So if I were to draw this line out, it would look something like this. Then, if I have a second line that has a line that looks very similar to this, we can see that the two lines intersect at this coordinate. That means that the solution is an x, y coordinate. It's because the lines intersect at one point. Now, lines cannot intersect at only 2 points or only 3 points because lines don't curve. Lines are straight, so they can intersect as long as the slopes are not parallel. If the slopes are the same and different y-intercepts, then they'll be parallel. But what if the slopes are the same and the y-intercept is the same? So if we have the exact same line, so the same y-intercept and the same slope, that means that these are the exact same line. If they intersect at all points, then it's called infinitely many solutions, meaning that they have the same line. A key difference here, or a key distinction, is that we cannot say that it's all solutions. The reason we can't say it's all solutions is because the coordinate -4, 5 is not a solution to that. So it's not all solutions. It means that there are an infinite amount of solutions that would work for this line, for this system, but it does not mean that all solutions do work. But the solution of 0, -2 does work. The solution of 6, 1 does work. Any of the solutions that are on the line itself, any coordinate that is on either of these lines, will in fact work. That just means that there are an infinite amount because the lines will go on forever. All solutions is not accurate because any coordinate that I pick on here is not necessarily a solution. So what we're going to do is, this video is going to showcase the different types of solving linear equations, solving a system of linear equations. We're going to use substitution, elimination, and graphing. We're going to use Desmos on the graphing aspect. So to use substitution, we are going to make sure that one of the equations is solved for a variable, and then we will plug the expression into that variable for the other equation. So for this first example, we already have the first equation solved for y, so we can take this expression and substitute it in for the other y. When we substitute it in for the other y, we will no longer see the letter y because that's what we're substituting. We're going to take the second equation. The y is what we are replacing. So I'm going to put parentheses. That entire expression of 4x minus 9 goes in for that y. Then we have minus x equals 3. We simplify this and we get 4x minus 9 minus x. So we end up with 4x minus x is 3x minus 9 equals 3. We're going to add the 9 to the other side. We end up with 3x equals to positive 12. We're going to divide by the 3, and we'll get x is equal to a positive 4. Now that we have the value of x equals 4, we can plug this x equals 4 back into either one of these equations so we can solve for y. Now this first equation, y is already by itself, so I'll actually focus on that one. I'll focus on y equals 4 times what our x value is, and then subtract 9. So we'll have y is equal to 4 times 4 is 16 minus 9. So y is equal to a positive 7. Therefore, the coordinate that these two lines would intersect at would be at 4, 7. So our solution is 4, 7. That means that our lines will intersect at one point. That means that these are not parallel and they are not the same line. This next question, I need to find a variable that I can easily solve for. So on the second equation, I see that y has a 1 attached to it, so we can easily solve for that y here. I'm going to have my y equal to a negative 3x plus 23, because we're going to subtract that 3x to the other side. Now that I have my y equal to something, I'm going to take this entire expression, which is equal to y, and replace or substitute it into the other y. So we'll have 8x minus 8 parentheses, that entire expression of negative 3x plus 23. And I'll close my parentheses equals negative 24. We use the distributive property to simplify. So we'll have 8x, negative 8 times negative 3x is a positive 24x. A negative 8 times a positive 23 is a negative 184, and that's going to equal to negative 24. We'll have 32x, I'll combine my x's, minus 184 equals negative 24. We will then add our 184 to the other side. We'll have 32x is equal to a positive 160. We will divide by 32, and we'll have x is equal to a positive 5. Now that we have x equal to a positive 5, I will plug this value into one of these equations, and I will plug it into my second equation just because it's smaller multiplication. So I'll plug it into 3 times the value of 5, because that's the x, plus y is equal to 23. When I simplify this, I'll have 15 plus y equals 23. I'll subtract the 15. We'll have y is equal to a positive 8. Now that we have the x and the y, our solution is the coordinate of 5, 8. And this happened because, again, I solved for the y on the second equation so that I can get the y by itself. So this expression, which is equal to y, is substituted into the other y in the top equation and then simplified down. For elimination, you want to have your x's, y's equals constants. If it is in that form, we can then look to see if our variables have the same number, which the x's do not, but the y's do. Then we also have to make sure that one's positive and one's negative. Since these are already in that form, we can go ahead and eliminate. So elimination, the whole point of elimination is to eliminate a variable by having them combine to 0. So we can actually combine these equations, because negative 7x and a positive 4x is a negative 3x. 4y and a negative 4y is 0, so those eliminate. Then we have 24 and 0, which combine to 24. We would solve for x by dividing by negative 3, so x will equal to a negative 8. Now that we have the x, we can substitute this x value into one of the original equations to solve for y. And again, it just is based off of what multiplication you'd like to do. I will plug it into my top one, so I'll have negative 7 times that negative 8, because that was the x, plus 4y equals 24. Simplifying that, negative 7 times negative 8 is a positive 56, plus 4y equals 24. I will subtract the 56, and I'll have 4y equals negative 32. I'll divide by the 4, and I'll get y is equal to a negative 8. So the coordinate, x is negative 8, and y is negative 8. Therefore, our solution is negative 8, negative 8. On the second example, we can see that we have x's, y's equals constants. So they're already set up in the way we need them. But if we look at our x's, no x value, or the value in front of your x, is not the same, and the value in front of your y is not the same. That means that we have to try and make either the x become the same number or the y's become the same number. It will not be easy to make 4 become a 7 or 2 become a 7. So that means that we will have to multiply both equations by a value. And it all depends on if you want to eliminate the x's or eliminate the y's. I will take the entire top equation and the entire bottom equation and multiply it by a value. If I want to eliminate the y's, I will eliminate the y's on here. I will multiply the top equation by the number on the bottom, which is 2, and I'll multiply the bottom equation by the number on the top, which was the 7. Because 7 times 2 and 2 times 7 will give me the same number. Now I have to make sure that my signs will be opposites. I'll end up with a positive and a positive, so I have a positive on the top. Positive times negative is a negative. I'll have a positive on the top and a negative on the bottom. Those will eliminate because they will combine to 0. We have to remember to multiply it to the entire equation because we are manipulating it, and manipulating means we're going to keep it the same value. It'll just look different. So our equations turn into the top will become negative 14x plus positive 14y equals a negative 42. The bottom equation, when I multiply by 7, will become a positive 28x, a negative 14y equals 22 times 7 is going to be a positive 154. Now that we have the same number and opposite signs, we can combine. We'll have a negative 14x and a positive 28x gives us a positive 14x. 14y minus 14y is 0 equals negative 42 and positive 154 is 112. We will divide by that 14 on both sides, and we'll end up with x is equal to 8. So our x value is 8. Now we'll take that x value of 8 and plug it into one of the original equations. I'll plug it into the bottom one because those are smaller numbers to multiply. So we'll have 4 times that 8, which is what we just found, minus 2y is equal to 22. Simplifying, 4 times 8 is 32, minus 2y equals 22. We'll subtract the 32 to the other side, so we'll have negative 2y is equal to a negative 10. And then we'll divide by that negative 2, so we'll have y is equal to negative 10 divided by a negative 2 is a positive 5. So our x value is 8 and our y value is 5. So our answer is 8, 5. Because this is the coordinate at which these two lines would intersect. The last method, which is graphing, can be done by changing these into slope-intercept form and finding the solution, or we can use Desmos. If we use Desmos, we're just going to type this in exactly as we see it. So 2x minus y equals -1, and negative 5x plus y equals -5. We type it in as we saw it. 2x minus y equals -1. There's our line in blue. And then we have negative 5x plus y equals -5. There's our other line in green. We're going to find the point at which they intersect, which happens to be at 2, 5. So our solution for this problem is 2, 5. When you do this in Desmos, you do not have to put it into slope-intercept form, so it makes it a little bit easier to do. This next problem, we're going to do the same thing. The second equation is in slope-intercept form, so if you wanted to graph it by hand, you could, but this top one is not, so that's okay because we're only going to use Desmos. We're going to type this in exactly as we see it. I'm going to delete these. We had negative 2x minus 5y equals 17. There's our line. And our second equation was y equals negative 4x plus 11. There's our second line. They cross right here, so the coordinate that they cross at is at 4, -5. So our solution is 4, -5. This was a video on how to solve systems of linear equations in all three different methods: graphing, elimination, and substitution. Again, you can have solutions that are zero solution, where the lines never intersect because the lines are parallel. Again, that means same slope, different y-intercept. You can have one solution to the lines intersecting when the lines cross one time, or you can have infinitely many solutions, which means that the equations were 100% the exact same. Again, that does not mean all solutions. You cannot put all solutions for a system of linear equations.